What is bond dissociation energy in chemical reactions? Imagine trying to pull apart two magnets stuck together. The force needed to separate them is similar to what bond dissociation energy measures in molecules. It tells us how much energy is needed to break a specific chemical bond between two atoms. When atoms bond, they share electrons, creating a stable connection. To break that bond, energy must be added, making the process endothermic. This energy is measured in kilojoules per mole, which means how much energy it takes to break 1 mole of bonds. For example, in a chlorine molecule made of two chlorine atoms, breaking the bond requires about 239 kilojoules per mole of energy. This is because bonds are stable arrangements of electrons, and breaking them requires input energy. Think of it like stretching a rubber band until it snaps. The more energy needed, the stronger or more stable the bond. Conversely, some bonds releases energy when they form. For instance, when two hydrogen atoms form a hydrogen-hydrogen bond, about 435 kilojoules per mole of energy is released. This releases of energy is what powers many chemical reactions. Bond dissociation energy is directly related to chemical energy, which is stored in bonds as potential energy. When bonds break, energy is absorbed from the surroundings. When new bonds form, energy is released back into the environment. This exchange is a key part of heat transfer during chemical reactions. For example, in exothermic reactions, energy is given off as bonds form, warming the surroundings. In endothermic reactions, energy is absorbed to break bonds, cooling the environment slightly. Knowing the bond dissociation energy helps us understand how stable a molecule is and how much energy is needed to change it. It also helps predict how fast a reaction might happen and whether it will releases or absorb energy. Stronger bonds requiring more energy to break, making them harder to split apart. We can calculate bond dissociation energy by comparing the energy content before and after bonds are broken. In essence, bond dissociation energy links the idea of chemical energy with heat transfer and energy changes in reactions. It explains why some bonds are tougher to break than others and how energy flows during chemical transformations. This understanding is vital for chemists designing new reactions, materials, or energy sources. It shows us how energy is stored, used, and released in the tiny world of atoms and molecules.